Hi everyone, we're going to continue with some Chapter 3 homework problems, and we're going to start with number 5. Convert the following from a heading to coordinates on a compass rose and vice versa. Here goes. There are 40 degrees east of south, so 40 degrees east of south. I'm just going to draw a nice north-south, east-west compass. And let's see if we can make sense out of this. Okay, 40 degrees east of south. North is 0, east is 90, south is 180, west is 270, and you go all the way around again, north is 360. So 40 degrees to the east of south, that means this is 40 degrees, is going to be a heading of 180 minus 40, or a heading of 140 degrees. Let's change colors and do the next one. A heading of 240 degrees. So a heading of 240, 180, 270, somewhere in here is going to be a heading of 240. Well, if this is a heading of 240, what's the difference between 270 and 240? That is going to be 30 degrees. So I'm going to call it 30 degrees south of west. All right, you could have said 60 degrees west of south, and that is also accurate. The next one, 300 degrees is what of what? So let's take a look at 300 degrees. If this is 270, that's 260. 300 degrees is going to be off in this direction. So what is that? Another way of saying the same thing? Well, that could also be, if that's 300 and that's 270, that would make that a 30-degree angle. So that could be 30 degrees north of west, or another way of saying it is 60 degrees west of north. Last but not least, let's do this one in red, 15 degrees to the west of north. There's north. We're going to go 15 degrees west of north, towards the west of north. This is 15 degrees. So what's that going to be a heading of? Well, true north, due north, is 360 degrees. We go to the west, so we subtract 15 degrees. That's going to be 10 minus 5. 5 minus 1 is 4, so 345 degrees. So it doesn't matter which way you say it. These can be said in many different ways, but you have to be able to convert one to another. Let's do another one. A strong wind is blowing at 30 miles an hour in a direction of 120 degrees. What is the component of the wind towards the south and towards the east? Now what we're doing is we are actually breaking vectors into components. So in a direction of 120 degrees. 120 degrees, east is 90, south is 180, 120 degrees is going to be right here. This is going to be 120 degrees, meaning this angle is 30 degrees, and this is a 30 mile an hour. We have a 30 mile per hour wind. I want to know how much of the wind is blowing towards the south and how much is blowing towards the east. So what I'm going to do is take this vector and I'm going to break it into components. So what I'm going to do is I'm going to make a triangle out of it. I can do this by dropping a perpendicular up towards east or left towards south. And I think just for room to write, I think I'm going to go up towards east. So if I go straight up towards east, this is, whoops, how about down towards south? There we go. That's what I want. This is going to be the southerly component, and this is going to be the easterly component. Okay, now what do? I now have a right triangle. I know the hypotenuse is 30. I know this angle is 30, and I have to find these sides. Well, the 30 miles per hour, this happens to be my hypotenuse. The angle next to my 30, this side is my adjacent, and the side opposite my 30, this side is my opposite. So I am actually going to use the cosine to find the easterly component, and I'm going to use the sine to find the southerly component. So let's go ahead and do that. The cosine of theta is the adjacent over the hypotenuse. The adjacent is my easterly component, so my adjacent is going to be equal to the cosine of my angle, 30 degrees, times my hypotenuse, 30 miles per hour. When I put those numbers into my calculator, and I'm grab my calculator here, 30 cosine times 30, I end up with, rounding off to 3 digits, I end up with 26 miles per hour. And that's going to be the component in the easterly direction. All right? Now, what about the component in the southerly direction? That is, I'm going to use the opposite, and I know the hypotenuse, so I'm going to go back and use sine. The sine of my angle is going to be equal to the opposite over the hypotenuse. I'm going to solve for that opposite because that's the part of the triangle I want. So the opposite is going to be equal to the sine of 30 degrees times my hypotenuse. It's a little algebra action going on there. And the hypotenuse happens to be equal to the sine of 30 times 30 miles per hour. The sine of 30 happens to be 1/2. So the opposite ends up being 15 miles per hour, and that is the southerly component of my motion. So that's breaking this vector into two components. Let's do one more, breaking vectors into components. Jeremy is swimming across the Mississippi River at a speed of 8.5 miles per hour at a heading of 290 degrees. What is his speed north and what is his speed west? Again, we're breaking this vector into components. So 290 degrees, that means we are going to be in this northwesternly coordinates. West is 270 and north is 360. This fellow is swimming at 290. 290 is going to be sort of like this, 290 degrees. That means this angle right here is a little 20-degree angle, and I want to know what is his component north going to be and what is his component west going to be. And here's my right triangle. The hypotenuse is the 8.5 miles per hour, and the angle I'm looking at is this one right here. So this side is the adjacent side. This is the opposite. Similar thing we did just up above. I am going to use cosine to find the adjacent side. So the adjacent is going to be equal to the cosine of 20 degrees times my hypotenuse, 8.5 miles per hour. And the adjacent side, which is my westerly component, is going to be, let me grab my calculator here, 20 cosine times 8.5, and I ended up with 7.987, round that off to 3 sig figs, essentially 8 miles per hour towards the west. Now, if I want to find the component towards the north, the northerly component, I'm going to use the opposite and my hypotenuse. That means I'm going to use sine. The sine of theta is the opposite over the hypotenuse. I want to solve for opposite. Ooh, get myself some more room. So the opposite is going to be equal to the sine of 20 degrees. The hypotenuse is the 8.5 miles per hour. This is going to give me my northern component. And again, pick up my calculator, 20 sine times 8.5, and I end up with 2.91 miles per hour if we're sticking to 3 sig figs towards the north. Alrighty, that should do for that batch, and we'll come back and do a few more in a bit. See ya.